Now, this is what we have seen so far in terms of definitions. We have understood what is feasible solution, what is basic feasible solution, when the degeneracy can happen in transportation problems, and of course, what is optimal solution. Now, let us proceed to understand how optimal solution of transportation problem is actually obtained. The method of finding an optimal solution of transportation problem will consist of two steps. The first step is we need to find out initial basic feasible solution, what we call it as IBFS. And the second step is to obtain an optimal solution by making successive improvements to initial basic feasible solution, that is initial IBFS, until no further improvement is possible. Now, in the world of transportation problem, as I have told you, the first step is to find IBFS. There are five different methods to obtain the IBFS for any transportation problem. So look at this. The first step, which says to find IBFS, we have five different methods. And then we proceed for optimality. There is no hardbound rule as to which method you should follow out of these five to obtain the IBFS, right? Unless otherwise it is stated in the problem statement, you are free to use any of the methods to obtain the initial basic feasible solution. Let us see what are those five methods. The first method is northwest corner rule. The second method is called as row minima method. The third one is called as column minima method. The fourth one is called as least cost entry method, or it is also called as matrix minima method. And the last one is called as Vogel's approximation method. As I told you some time back, you are free to use any of these five methods to obtain the initial basic feasible solution for any transportation problem. Now, the transportation problem has a solution if and only if the problem is balanced. Therefore, very important thing is before we make an attempt to find the IBFS, we need to check whether the given problem is balanced or not. That means the total supply should be equal to the total demand. Only when this happens, the given transportation problem is said to be balanced. Otherwise, it is called as unbalanced transportation problem. And believe me, if the transportation problem is not balanced, IBFS will not work. And hence, it is mandatory for OR professionals to ensure that before implementing any of the five methods to obtain the IBFS, we need to ensure the transportation problem is balanced, right? So initially, we make an attempt to solve the problems, assuming that the transportation problems are balanced, and then when it becomes unbalanced, I will tell you how to proceed in order to make it balanced and then implement the methods. Now, let us see the first method, what is called as northwest corner rule. These are the steps involved. I request you to go through it and then I'll explain you this method directly with the help of the example. Okay, now let us try to solve a problem. Using northwest corner rule, find IBFS for this particular problem, right? Now, let us have a close look at this particular problem. This particular problem is having 3 rows and 4 columns, where the 3 rows belongs to the factories and the 4 columns belongs to the warehouse. It is there in front of you. Microsoft Word will be more easier for us. Now these are the 3 factories, right? So 3 rows, and these are the 4 columns, that is 4 warehouse, right? Now the supply at each factory, factory F1 is 7, factory F2 is 9, factory F3 is 18. So this is the supply. The total supply of all the 3 factories put together is 34. 7 plus 9 is 16. 16 plus 18 is 34. Similarly, let us look at the demand, what we call it as warehouse requirement at each of these four warehouses. The demand at warehouse 1 is 5. The demand at warehouse 2 is 8. At warehouse 3, the demand is 7, and the demand at warehouse 4 is 14. So the total demand is 5 plus 8 plus 7 plus 14, which is 14 plus 7 is 21 plus 8, 29 plus 5, 34. So the total supply is 34, the total demand is 34. So total supply is equal to total demand. So it is called as balanced transportation problem, right? Now, just try to understand the slight difference between the so-called balanced problem in transportation and assignment. If you recollect, in case of assignment problem, balanced assignment problem means are those problems where number of rows were equal to number of columns. That definition does not hold good in transportation problem, right? In transportation problem, if supply is equal to the demand, irrespective of the rows and columns, the problem is said to be balanced transportation problem. You look at this itself. You have 3 rows, that is 3 factories, and 4 columns, that is 4 warehouses. So the order of this matrix is actually 3 cross 4, right? And if this was an assignment problem, we would have drawn conclusion that this is unbalanced assignment problem. But that is not the case over here. Now, what we do is, let us see how to implement northwest corner rule to get IBFS for this particular problem. Now, if you try to recollect the structure which I told you earlier in the earlier video, this particular 19 is the cost involved. As a matter of fact, whatever is highlighted now in front of you on the screen is the cost involved, meaning this 19 is the total cost involved in shipping one product from factory F1 to warehouse W1. Similarly, 70 is the cost involved in shipping the product from F2 to W1. And just one more last, this 20 is the cost involved in shipping product from factory F3 to warehouse W4. Okay. Now, with this information with us, the cost involved, the total supply, and the total demand, let us see how we implement northwest corner rule to obtain the IBFS. So, a different version of the same matrix I have drawn here with these things removed, right? Now, what actually your northwest corner rule says is, it says that you start all the way from top, that is from cell 1 1. You start from row 1 column 1 and you proceed. So what it says is, when you go to row 1 column 1, in that particular cell you allocate as much as possible such that you satisfy the supply and the demand requirement, right? Now, if I want to allocate here in cell F1 W1, the demand is 5 and the supply is 7. So I need to allocate as much as possible, keeping supply and demand in mind. So I have 5 here, I have 7 here, so I will allocate 5. Now please try to understand. I said you are supposed to allocate as much as possible, but you are supposed to keep supply and demand in mind. Do not draw conclusion that when I say as much as possible, it is maximum among this 5 and 7. No, 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 no. You have to keep supply and demand in mind. See, what happens is, suppose if I put 7 here and I say the total factory 1 is going to supply 7 products to W1. Okay, now factory 1 has got 7 as supply, but what is the demand of warehouse 1? It is 5. If the demand of warehouse 1 is 5, how can you supply 7 products to warehouse 1, right? So that is where you have to be careful, right? So I can supply only 5. Now, whenever you put or whenever you fill a particular cell using northwest corner rule, it is possible that it will take care of either a row requirement or a column requirement. Once I have put 5 here, it is going to take care of my column requirement. because the warehouse 1 demand is 5 and warehouse 1 is getting the entire 5 products from factory 1. So warehouse 1 demand is over. Once the warehouse 1 demand is over, warehouse 1 cannot get the products from factory F2 and F3, right? So what Northwest says is, once the column requirement is over, you go to the next column. Now let us come to F1 W2, right? Now warehouse 2 demand is 8, factory now the supply is 7 minus 5, because already I have given 5 here, so that is left over here is only 2. So I have 2 here and I have 8 here, so I will put 2, right? Now watch out, 5 plus 2 is 7. The total supply of factory 1 is over, so I cannot supply any more product from factory 1. That means what this row says, factory 1 cannot supply any product to warehouse 3 and warehouse 4. Now watch out. Once this row requirement is over, this 5 plus 2 is equal to 7. You proceed to the next row. That is what the northwest corner rule says, right? I repeat, in northwest corner rule, if column requirement is over, proceed to the next column. If the row requirement is over, proceed to the next row. Now I'll come down here, right? Now here I have 8 minus 2. 2 is already over. 8 is there. So I have left over with 6. And this is 9. So I can have 6 here, right? So 2 plus 6, 8 is over. That is W2 demand is taken. So I'll put a hyphen here. The significance of this hyphen is the products cannot be supplied from that particular factory to that particular warehouse. So column requirement is over. I'll go to the next column. Here I already have finished 6 out of 9. So left is 3 and this is 7. So I'll supply 3 here. So watch out, 6 plus 3 is 9 and hence my row requirement is over, right? Now you don't need to basically go with respect to the algorithm or the methodology of Northwest. You can directly or blindly fill it up. Now already 3 is over, so I will fill it up 4 here, and already 4 is over, and out of 18 I'll fill 14 here. Now watch out, right? 5 plus 2 is 7, fantastic. 6 plus 3 is 9, beautiful. 4 plus 14 is 18. Similarly, this is 5, 2 plus 6 is 8, 3 plus 4 is 7, and this is 14, right? So this particular matrix tells me that factory F1 will supply 5 products to warehouse 1. Factory F3 will supply 4 products to warehouse 3. Now this is the supply from each factory to each of the warehouse as far as this particular problem is concerned. Now please understand, this is only initial basic feasible solution. Now what we have to do is we have to find out the cost involved in supplying the entire products. As I said, you are supplying 5 products from factory F1 to warehouse 1. On the other hand, in the problem statement that was given to you, it was told that to supply one product from factory F1 to warehouse 1, it involves or it costs 19 rupees. But you are supplying 5 products, so the total cost will be 5 into 19 as far as your first supply is concerned, right? So I have 5 into 19. Similarly, I will add up all this. So this is 2 and that will be multiplied by 30, right? So that will be 2 into 30. Similarly, I proceed. Okay, so when I add and when I multiply and add, I will get 1015, right? So what does this signifies? That 1015 is the total cost involved in shipping the products from these 3 factories to these 4 warehouses using northwest corner rule, right? So this is how your northwest corner rule works. Let us take one more example. I have example 2 here, and this is what I have with me, the problem statement. And then the supply is 14 plus 16 plus 5, that is 35. And the demand is 6 plus 10, 16 plus 15, 31 plus 4, 35. So the supply and demand is same. So it is balanced transportation problem, right? Now I'll just try to fill the cells. Just try to understand. I start from first row, first column. I put 6 here, taking care of my column requirement. I will go here. I will put 8 here. That will take care of my row requirement. Then I will go here. I will put 2. That will take care of column requirement. Then I proceed. I put 12. I have this. I'm sorry. I can put 14 instead of 12. So I put 14 here. Then this is over. Then I put 1 and I put 4. Right? And then I proceed in terms of calculating. So it is nothing but 6 into 6 plus 8 into 4 plus 2 into 9 plus 14 into 2 plus 1 into 6 plus 4 into 2. So when I multiply and add, I will get 128, right? So 128 is the IBFS obtained for this particular problem using northwest corner rule.